Hi everybody, we are on the page 8 of our blue folders. We're going to talk about solving and graphing quadratic functions and what they are and all of that. So let's go ahead and start with looking at this little folder right here. We're going to call it parts, or folder, fold out. We're going to call it parts of a parabola. P-A-R-A-B-O-L-A, parts of a parabola. Remember, a parabola is that U-shaped or N-shaped curve that we have. Okay? Alright, so let's open it up to the inside, and we're going to use some colors to kind of highlight some things inside here. Alright, so if we're looking at this graph, this is just kind of vocabulary for you everywhere. We're going to start with the axis of symmetry, and that axis of symmetry is basically just the line that divides the parabola into two parts. So here's the word for axis of symmetry, and this one is actually just on the y-axis. And when we write our axis of symmetry, we say that's going to be x equals, because it's a vertical line, and remember that's VUX, so V-U-X, so vertical line means that I use x for my equation. Alright, let's just go up the list here. Let's talk about y-intercepts. So y-intercepts are where they cross the y-axis at, and in this graph it's just at the very bottom, right there on that axis of symmetry. And so that's going to be at -4. So we say 0, -4. That's what a y-intercept is. It's where it touches that y-axis. Alright, the next thing we're going to talk about is roots, zeros, and solutions, and x-intercepts. Those are all exactly the same thing. So roots, zeros, x-intercepts, they are literally the exact same thing. So I'm going to color them all the same thing. But they're over here in the graph. They are right here where they cross the x-axis. Okay? So we can list it as x equals, and this one's at -2 and 2. So we'll say the same thing here. Why am I going to write negative twice? -2 and 2. And same thing for the x-intercept. And sometimes they might call these things solutions. That is the same exact word as well. So remember, 4 different names for it, so pay attention to that. Look out for that when you're doing your test. 4 different names. They all mean the same thing that we're talking about. Where does it cross the x-axis at? Okay? And the last one they're asking for is the vertex, and that one is going to be the highest or the lowest point on the graph, the minimum or the maximum value. So there's vertex, and on this graph the vertex happens to be the y-intercept as well, so it's 0, -4. The vertex is not always the y-intercept. Sometimes it's in a different place. But for this particular graph, it was the y-intercept. Okay, so that is parts of a parabola. Let's go look over here at this teeny tiny book we made with only 1 page in it, which is kind of fun. And we're going to talk about how to graph. So what you're going to do is, if they ask you for the axis of symmetry, you need to practice that work where we say -b/2a. So remember, in this equation, a, that's -3, b is +12, and c is -5. Okay? And so what you're going to do is you're going to put it as -b/2a. So -12/2 times -3. And you type that in on your calculator, and that's -12/-6, which is +2. So our axis of symmetry is a vertical line because it says x equals, so VUX, at positive 2. So I'm just going to go ahead and draw that axis of symmetry over here. That's my axis of symmetry. Okay. Alright, it says put the vertex, find the vertex. So you put the answer into the axis of symmetry function. Okay. So the vertex is going to be, I'm just going to type this equation into the calculator to find my vertex. I know it's going to be at x equals 2, so I'm going to look at my table and see what the other value is for y. So negative 3x squared plus 12x minus 5. I like to use my tools to my advantage. So it's 2, 7, okay? So the vertex is at 2, 7. So 2, 1, 2, 3, 4, 5, 6, 7. And put a dot. There's my vertex. Okay? And then what is the y-intercept? So the y-intercept, that's when x equals 0. And the y-intercept is at negative 5. So that's my y-intercept right there. And so if I have that point and that point, I can kind of draw a graph going this way. And then I know that my axis of symmetry is going to be a mirror. So I know I can go 2 on the other side and get my other point that's going to be on my graph. Because my axis of symmetry acts as a mirror, and that's my matching point. Okay? Alright, let's talk about solving quadratic equations. So we're going to do this big one right here. Okay, so we're going to talk about factoring. So if we're going to factor, the very first step to factoring is to make sure that we set the equation equal to 0. Okay? You have to make sure the equation equals 0. Okay? This only applies when we're talking about something with an exponent of 2. So that means I need to move the 10 over, and I need to move the 3 over. So if I cross this line right here to make it equal to 0, then I need to make that negative 10 and positive 3x. So I'm going to rewrite it. Positive 3x and negative 10 equals 0. Okay? So to factor this, this is a trinomial, so I'm going to do the box. Okay? So the first thing I do is I'm going to multiply a times c, and a times c equals negative 10. So I'm going to make my table with negative 10. That's 1 and 10, 2 and 5, and there's really nothing else in my table. Then I'm going to make my box, and I'm going to fill in the things that I know already. I know x squared, and I know negative 10. Now, since this is negative, that means I'm subtracting in my table. Okay, so 10 minus 1 and 5 minus 2, I'm trying to get 3. And 5 minus 2 is going to get me 3. So I'm going to put negative 2x here and 5x here. And then I'm going to find the GCFs. So I cover up the bottom. The GCF here is x, and what goes on top is going to be x to get you the x squared and 5 to get you 5x. Okay, it's just like a Punnett square in biology. Just multiply x times 5, x times x. Then we have to figure out what goes down here at the bottom. So I'm going to cover up this side. And if I want to get negative 2x, I have to say negative 2. So my factors are x minus 2 and x plus 5. And that's equal to 0. And remember, this is factored form. Okay, that's factored form. Now, if I want to solve this, I'm going to put each one equal to 0. And I'm going to solve. Okay, so this means I add 2 to both sides to get x equals 2, and I subtract 5 from both sides to get x equals negative 5. Okay? And those are my 2 answers to this problem. Now, don't forget, you also have problems with GCF. So I left a little space over here, so I'm going to do a quick GCF problem. It's going to be really fast. Let's talk about if we have 4x squared minus 12x. Okay, that's a binomial. There's only two here. Let's make a big, these are kind of connected, so this is just another example, okay? So we put those inside the box, divide it into two pieces. The greatest number that goes into 4 and 12 is 4. So we have 4, and they both have x, so I'm going to say 4x. And then up top here, to get 4 times what gets me 4x squared? That's just plain x. And 4 times negative 3 gets me that negative 12. So I have 4x times x minus 3. And that's just if I wanted to factor a binomial. Okay? Alright, the next type of solving is taking square roots. And taking square roots is super duper easy. All you do is take the square root of both sides. Now you can do this in 2 or 3 different ways. If the answer tells you in a decimal form, then all you do is type that 192 on your calculator. If the answer tells you to simplify the radical, then that's where you're going to say, okay, 192, and you go, okay, I can divide that by 2, and that gets me, should have written it lower. Remember, you do the cake or the tree method? So I'll put it down here, 192 divided by 2, that gets you 96, and then 96 divided by 2, sorry, I haven't done this yet. 96 divided by 2 is 48, and then 48 divided by 2 is 24, and 24 divided by 2 is 12, and 12 divided by 2 is 6, and 6 divided by 2 is 3, and then 3 divided by 3 is 1. Remember, you want to divide till you get your birthday candle at the top. How many pairs do I have? I have 3 pairs of 2 with a 3 left over. So this is 2 times 2 times 2, square root of 3. 2, 4, 8, square root of 3. Okay? Alright, the next one is completing the square. I have not taught you about completing the square. However, you need to be aware that completing the square is a method for solving quadratics. Just because they might ask you which one of these is not a method for solving quadratics, and so you need to know that completing the square is a method. So I'm just going to say here, it's a method, but you don't have to know how to do it this year. You'll learn it in Algebra 2. Alright, don't forget about the quadratic formula. So remember, that one is one boy, a negative boy, went to a party, and he was a square boy, and he met 4 awesome chicks, and the party ended at 2 a.m. Or negative b plus or minus the square root of b squared minus 4ac all over 2a. So to do this problem, we need to know what a, b, and c are. So a is negative 3, b is 6, and c is 4. Okay? So this is negative parentheses plus or minus square root of parentheses squared minus 4 parentheses parentheses all over 2 parentheses. And I used to color code these, so I'm going to go ahead and color code them now. That's A. A is on the bottom. This is B for boy. I'm going to use blue. B squared. And we've got another A at the top. And then lastly, we've got C. I'll use my ugly yellow for that one. Alright, so we'll plug them in. So 6 goes here, 6 goes here, negative 3 goes there, 4 there, and negative 3 there. And then you just type this into your calculator. How many times do you type it? You type it twice. The first time you type it into the calculator, you type it with plus. and one with minus. Okay? When you type it in, go ahead and give yourself a chance to type that in, so you might pause the video so you have an option to. Type it in, you get 2.53 when you round it. And then the other answer is x is about negative 0.53. Those are the two answers when you type this into your calculator. Okay. Alright, the last one on this little flip chart is talking about graphs and tables. Graphs and tables are where it crosses the x-axis. It's the x-intercept. So on graphs, we want to know, where does it cross the x-axis? And on tables, we want to know where y equals 0. Okay? So on my graph here, it crosses the x-axis at around 3 and around, I don't know, let's count. So 2, 3, 4, 5, 6, 7, 8, 9. So this is x is 3 and x is 9. Remember, you could also write it with the squiggly lines. I just didn't. Okay? And let's ignore the directions up here because I don't like them. Okay, so let's go ahead and make this table over here too. Actually, I kind of do like them. I told you to cross them off, but now that I think about it, I kind of do like them because sometimes they don't ask us for us to solve where it crosses the x-axis or where y equals 0. Sometimes it asks us to say, hey, when does it equal 6? So that's our y value is 6, right? So that on this table we would say, where is it 6 on the table? But then over here, it's where is it 6 on the graph. Does that make sense? So let's fill in the table for what we know. So this is 2, 3, 4, 5, 6, 7, 8, 9. Okay. And this is 2, 3, 4, 5, 6, 7, 8, 9. Okay, so 3 is at, actually 3 is at 1. And 4 is at 6. 5 is at 9. 6 is at 10. 7 is at 9. So now we're following our pattern, right? 8 is going to be at 6. And then 9 is going to be at 1. So like I said, it was about 3 and about 9, but really it wasn't exactly. So let me change these to say about 3 and about 9. That's for if we're solving for when h of x equals 0. Okay, so here it asks for when it equals 6. So we're going to look on our table, that's at 4 and 8. And on the graph, we're going to look at when y is equal to 6, and that's in the same places. So for this one, it's going to be at 4 and 8. Okay? Okay? Alright, so that is solving quadratic equations. Lastly, let's talk about shifts in quadratic equations, which is going to be this one down here at the bottom. And it's called changes in A and C. Remember, it's ax squared plus bx plus c. If they have parentheses, that c is always that number added outside of the parentheses. Okay? Alright, so let's go ahead and look at this first side. If c is added to the graph moves upwards. Okay? If we're adding c, if it's getting bigger on the c part, then the graph is moving upwards. If we are subtracting, then the graph is it's going to move down. Okay? So right here, plus 3, that means the graph moves up from its original form. So see how it moved up to 3 on the graph up here? And then if we're going to subtract 3 at the end of it, it's going to move down. So see how this graph is 3 below our original one, which went through the origin. Okay? Alright, over here we've got a couple of things. If A is positive, the graph opens upward. So positive means it opens upward. If A is negative, the graph opens downward. We're going to show that using the blue. So we have negative x squared, and here is our graph opening downward. Oh, I highlighted the wrong one pink, I'm sorry. It should be the dotted one that's pink. We'll use orange for it to stretch. So it says if A is larger than 1, then the graph is a stretch, and it gets wider. So let's use orange on that so that the pink and the orange kind of blend together. And you can't really tell that we messed up. Okay? And then it says if A is smaller than 1 but also bigger than 0, okay, the graph gets thinner or shrinks. And we can use pink on that one because I'm running out of colors. Actually, let's use green. So the graph gets thinner, like a half. And so here is the graph where it was a half. Okay? Alright, so that is page 8 wrapped up. We've got page 9 coming up next. It is continuing to talk about quadratics, but I will do that one in a different video. Thanks for watching.